Okay, hi class. This is second part of chapter 2. So we are going to study what is EMF, what is internal resistance, and what is the factor affecting resistance. Okay, so look at this thing. Okay, so EMF is actually, the unit of EMF is also voltage. If you compare EMF with potential difference, it is actually quite similar. If you still remember, potential difference is the energy that required to carry one unit of charge from one point to another point, right? Okay, so let's say this is our circuit. We have a battery here. Okay, so from point A to point B. Okay, so the energy that needed to carry the charge from point A to point B, that is what we call potential difference. So how to measure potential difference? We just connect voltmeter here, right? Okay, so what is EMF? So EMF is also energy. It is energy to carry one unit of charge, to complete the whole circuit. Okay, to complete the whole circuit, right? So it's the energy to carry one unit of charge to complete the whole circuit. So if you look at the unit, EMF unit will be voltage, right? And then one unit of charge is current, right? Okay, so it's to energy to carry one unit of charge. So it is like this. Energy is joule, carry one unit of charge. So this is the unit. So voltage equal to joule per coulomb. So this is what we call EMF. And still remember yesterday I said if this is a school field, the energy for Jasper to run from point A to point B, we call it potential difference. But the energy for Jasper to run from point A back to point A, that is what we call EMF. Slightly different, but actually it's quite similar. Okay, now what is internal resistance then? Internal resistance, normally we write it as a small r. We write it as small r. So imagine that you have a battery. That battery cannot be resistance free, right? Somehow battery sometimes it will get hotter also, right? Means that they are actually resistant in the battery itself. If you still remember in your chemistry, you learn simple cell, right? Okay, you learn simple cell, you have a ref start here, and then probably you have milliammeter here, and then this is electrolyte. The liquid inside, we call it electrolyte, right? Electrolyte. And this is what you call electrode. Okay, so the resistance in the electrolyte between electrode is what we call internal resistance. Okay, is that clear? I repeat. So internal resistance, small r, we call it resistance between electrode in electrolyte. Okay, so that is, of course, the unit will be ohm also lah. Okay, so how to link resistance, big resistance and small resistance together, and then how to link EMF, electromotive force, and potential difference together. So we have a formula. Okay, again I need another circuit. So this is big resistance, and then we have, imagine that we have small resistance inside. And then the power supply is EMF, because you have to complete the whole circuit, right? So it's EMF. Of course, the potential difference will be from point A to point B. So this is voltage, potential difference lah, we call it. Okay, so you look at this circuit. This is series circuit, right? So when it is series circuit, resistance will be the sum of resistance, right? So we know that from Ohm's law, V equal to IR. Okay, assume that you still remember this. Okay, so what is the voltage here now? If we consider the whole circuit, the voltage here will be EMF, right? Okay, and then the resistance will be big R plus small r, because this is series circuit. And then we expand it, IR plus IR. Then we come back to this one. IR, isn't it equal to voltage? Which means it is potential difference. So EMF equal to potential difference plus IR. Okay, so I have a new equation here. This is a new equation that actually link all potential difference, EMF, internal resistance, and big resistance. So if I draw a graph, okay, so this is I, ampere, this is V, voltage, right? Okay, now this is my y-axis, this is my x-axis, right? So look at the formula that we get just now. Okay, means that this is my x-axis, right? And this will be my y-axis, right? If this is a linear equation, let's say this is it's obeys Ohm's law, ohmic conductor, then we have to say that y equal to mx plus c, right? So we have to arrange whole thing here in this shape. Okay, so y will be here. I will bring this thing another side. So y equal to mx plus c, right? V equal to negative IR plus EMF. Okay, since this is my x, this is my gradient, right? So I will expand it like this. Okay, so if I compare to y equal to mx plus c, it is very clear that negative r is actually the gradient and EMF is actually the y-intercept, we call it. Y-intercept is actually y-EMF. If you carry out experiment and you connect your battery, then you will get a graph like this. Okay, because this is negative value. See that? Negative value. So your gradient will be negative. Means that the gradient represent internal resistance and the y-intercept actually is the electromotive force. I would say that this is the hardest part of chapter 2, which is very easy, right? I think you guys can easily catch up and understand this. Okay, so normally in exam, how are you going to differentiate when it is the question asking about this thing, or when we have to use this one? We have two formula. It is quite confusing, right? So it's very easy. If you see that the circuit like this, if you see that the voltmeter connected like this, okay, so we will use normal formula Ohm's law lah. So if you see that the the voltmeter connected over here, okay, then you know that it is the biggest. We are going to use this. Okay, V plus IR. Okay, we have two different circuit here. Look at the position that the voltmeter is connected. Alright, okay, so after this one, we are going to talk about factor affecting resistance. Okay, so factor affecting resistance. So resistance, actually, if you look at the old syllabus, it's actually given a formula. This is the resistivity of material rho. Means that different material, you have different resistivity. Like different person, you have different character, right? And then L is the length of the wire or the conductor. A is the cross-sectional area of the conductor. Okay, so if the wire is very long compared to another one very short, if it is very long, okay, the resistance of course will increase, right? You like resistance or not? Of course we don't like resistance, right? Okay, so the longer the wire, the higher the resistance. And then another one is A. Okay, one is very fat, another one very thin. So you see that the cross-sectional area A1 and A2. A1 is bigger, right? Bigger or larger cross-sectional area. So when the A is greater, resistance will drop. You see that the space given is greater. It is bigger, right? So it is easier for the electron to move around compared to the one that very fine. Normally we know that fine wire can get heated up easily. When the temperature is very high, the resistance is very high as well. Okay, so another one is this one, like resistivity. So this one resistivity based on type of material. We know that there are many kind of wire that we use. Of course, gold is the best, but we don't really use gold unless you are very rich. So we actually use copper wire. Okay, we use copper wire. That is the normal practice lah. So what is another factor? We have 4 factors. 1, 2, 3, and 4. What is another factor that affecting the resistance of a conductor? Will be the temperature, right? You know, when you play phone and then your phone getting hotter, so what you have to do? Okay, so you will try to cool it down, right? Because when the temperature is higher, the resistance is actually also higher. And you have to remember that if we have filament light bulb, when the temperature is higher, it's getting brighter. The light getting brighter. Okay, so they are all together four factors that affecting the resistance. Okay, so now I still have one more parts, that small parts behind, that is efficiency, energy, and also power. After every chapter, we always have to talk about efficiency, energy, and power. So it is too much for you today lah. I think we have this. Okay, one last question. What kills? Okay, what kills? Is that current or voltage? Okay, so whoever that can answer this question accurately in fastest mode, I give this. What is this? Cha time. Thinking how? Okay, try to get your reward here. Okay, so for this one, a lot of people are going to say, okay, either just current or voltage that it kill. Some people say both of them are actually equally responsible. So we don't really know what is that, so I'm waiting for your answer. Thank you, class.